Hey, welcome everyone. Let's give it a couple of minutes for everyone to join. Make sure to like and retweet spaces. More people could join, and we are starting in a couple of minutes. Okay, looks like we had a couple of minutes. Let's start today's spaces. Hi everyone. My name is Endo, community manager at Nexa, and welcome everyone again to today's Nexa Spaces on X. This space is the first one of many more we are going to have in the coming weeks and months. Today we are here with Bitcoin Unlimited founder and Nexa lead developer Andrew Stone, and we are going to talk about the conference in Australia, and we'll have a little overview of Nexa. Just a couple of weeks back, he presented Nexa at the Australian Crypto Convention 2024 and talked about Nexa and Atomic Secret Exchange and private NFTs. So, hello and thanks for joining us today, Andrew.
Hi.
Pleasure to have you. Maybe let's start with Australia and Sydney itself. I think that the community is interested to hear how it went. Did you have a chance to explore Sydney or maybe had any favorite spots, experiences there apart from the continent?
Yeah, I spent a few extra days there. It's definitely a beautiful place. I'd never been to Australia before. It was warm compared to where I live now. It was, summer was just beginning. I went, swimming in the ocean. We went to the zoo to see some marsupials. Had a kangaroo steak. Isn't it a little odd that we go to a different place and we eat the native animals? I guess unless you're a vegan. But anyway, it's beautiful, beautiful, wonderful buildings there too.
Yeah, it was supposed to be a really nice experience. I can sign on that myself. I also participated in the event and experienced Sydney a bit. It was really awesome. Let's jump to a major topic today and the Australian Crypto Convention itself. What were your impressions of the conference overall?
I'd never been to a straight up crypto conference like that before, so I found it really interesting. I've been to like cryptocurrency developer conferences, which is a very different situation. I guess it was very busy, like 9,000 or so people showed. I think obviously the price appreciation of Bitcoin drove a lot of interest. Our booth was easily visible from like the front door. You kind of walk in the front door and you would walk down the main, corridor straight ahead, and then we were like just to the right. So we got a lot of traffic moving through. People were always talking um, to people coming by asking what Nexa was. And I think one thing that I took away from it is that a lot of people had no idea, hadn't heard of Nexa before. So we definitely have a lot of, which is a good thing, right? We've got a lot of people to educate.
Yeah, that's very nice. We had amazing spot in the conference itself. I was amazed to listen to your speech, very high quality content. In the beginning of your speech, you introduced Nexa at the conference. For those who might be hearing about Nexa for the first time, can you give us a brief overview?
Yeah, so I think we kind of decided that in the AMA today, I would just talk about the first half of my speech because the second half on Atomic Secret Exchange is obviously a whole nother story. And it was hard to cram in all of that into the one speech. But I was able to get through it. One thing that I want everyone who listens to it to understand um, that this actual venue for speaking was not that great. There was loud. It was open to the floor, right? There was like these. I don't know what you call them. Um, modesty walls. They go up about chest height to frame the space and everything. But the issue was noise, right? It was very hard to even hear myself talk. Of course, I guess I couldn't tell if the audience could hear me. It was that loud, but they could because, of course, I was mic'd in the speakers, right? Um, However, that was very distracting. So if you listen to my speech, I'm going over content that needed a lot of focus, and I kept getting distracted. So that's the one thing I would say was unfortunate. Um, but yes, so the beginning, it was clear that I needed to introduce Nexa to the listeners, and and so that's what I did in the beginning. Um, And the room was about maybe 25% full at the beginning, but by the end, it was about 100% full. It was I wasn't doing a count, but it was full. And I think the issue there was it was the first speech of the day, and so people were still trickling in. So Nexa, well, I think hopefully some of the listeners will know, but the key distinction, especially with Ethereum have dominating like the development and a lot of the NFT spaces and everything, is to contrast Nexa against that, with Bitcoin sort of focused on digital gold and only on itself, right? You're left with Ethereum, but Nexa is trying to bridge those two ideas, and so it's a UTXO family blockchain, which means coming from the Bitcoin world, and it's proof of work chain, peer-to-peer, decentralized, anonymous, permissionless, has 2-minute blocks, which is just a practical consideration. Bitcoin, if you these are average block times, so you could easily, have to wait a couple times that long, say 5 times that long. Okay, so with 2-minute blocks, that's a 10-minute wait. That's not that bad. With something like Bitcoin, that's like an hour wait. That starts to feel really painful. So it was just an easy thought to bring the block size down to something more reasonable. Actually, I want to say one more thing, which of course is that it is a fairly launched blockchain, which you don't see too many of anymore. That means that Bitcoin Unlimited, we didn't give ourselves any any initial coins, and also we chose the Bitcoin coin reward system of dropping in half every 4 years. So we chose that because people are monkeying with that reward projected reward system to claim fair launch, but how fair is it to, for example, issue, I don't know, 90, 80, 75 to 90% of your coins within the first few years. And then, of course, in those years, you're just kind of quiet, right? So it's really the insiders who are doing the mining. And then after all those coins have been issued, you burst out, right? So we chose to say, no, we're going to effectively prove that we're not monkeying with stuff like that by simply choosing the Bitcoin emission, which, is not our choice. So we couldn't have been fooling with it. And so, in the first 4 years, it does produce about half of the coins, and then the next 4, a quarter and so forth, which is actually a much slower, more drawn out emissions than a lot of the newer coins that trying to push things. That's kind of the overview of the blockchain and the Nexa's tokenomics. Oh, final thing. If you look and you say, oh gosh, there's, Nexa's producing so many coins, right? We get that all the time. It's because we just moved the decimal point, right? So if you look at the finest unit, we're going to produce the same number of the finest unit, which we both call Satoshi, as Bitcoin, right? The difference is that one Bitcoin has 100 million Satoshi in it, whereas one Nexa has just 100, as in pennies, right? Nexa Satoshi. And, there's lots of reasons to do that. The main one is because a lot of systems like 2 decimal places, economic systems, but other reasons are, as Bitcoin is seeing right now, like, cross our fingers. But like the retail doesn't want to buy spend $100,000 for anything really, other than their houses. So that's it. That's the blockchain and tokenomics.
Yeah, that's true. That's true. Thank you a lot for that. It sounds really exciting from first lips. I think what is really exciting also it's the history of Nexa and Bitcoin Unlimited. I know that you as individuals started to work on Bitcoin itself from as early as 2012, if I'm not wrong. So how and when did it started?
Right. So I was an investor in Bitcoin. I discovered Bitcoin in early 2012. I didn't start working on the code until around 2017 during the Bitcoin's block size wars, which interestingly enough have flared up again. It appears on X and other media. So obviously I was on the side of scaling Bitcoin in a natural and reasonable way, as in increase the block size because networks and processing power and so forth has improved dramatically. So, that fight happened, and the I hate to say that we lost because the fight is clearly rearing its ugly head again, or its happy head. However, those people who were in charge stayed in charge, right? So we effectively gave up on Bitcoin and forked Bitcoin Cash, and a bunch of different community members moved in. At that time, Bitcoin Unlimited really was not the mining majority. At one point, we had the majority of nodes for a long time, actually, but not the mining majority. So we were unable to drive changes into the network. And I strongly believed, and actually in a speech in the first Bitcoin Cash conference in Japan, this is what I spoke about, that in order to counterweight Bitcoin's first mover advantage, we needed to innovate on the chain rapidly. So I proposed a couple things, group tokens and so forth. But these changes were not, didn't make it into Bitcoin Cash for a variety of political reasons and so forth. So Bitcoin Cash had a strong philosophy of if we just increase the block size, then that's all we're going to need. I think that philosophy, even now, has been completely destroyed. And so Bitcoin Cash is finally innovating as well, which is great news for them. But years prior, we had started to go our own way with a variety of innovations, all of which are now packed into Nexa.
Yeah, that sounds awesome. Bitcoin Unlimited and Nexa developers are the veterans in the space. This is really exciting. Um, Speaking about goals, can you share your personal goals or building Nexa or even the mission of Nexa itself?
Yeah, so what I presented in my speech is, hey, like Nexa being a commodity can't really have a mission because there isn't like an organization behind it, right? But my goal in founding Nexa is to create sound money cryptocurrency for everyone to use every day. This is a hard goal, right? And Bitcoin has moved to a simpler goal, which is store of value, right? Digital gold, and its transfer capabilities and so forth simply support that. Um, and then Ethereum, I believe, feels a lot more like a complex and esoteric financial contract system where maybe quants and PhDs will write clever scripts and contracts to offer credit default swaps or whatever these things are, right? And then typically information advantage will screw over the end user. I mean, I'm just this is my personal feeling. So I wanted to create money that you just have on your phone wallet and you could just use. Obviously, massive scalability is an important part of that, and there's other pieces like tokens, very efficient tokens, stuff like that.
Yes, definitely. I also saw a presentation for many of times. During the presentation, you have mentioned that Nexa, that some of Nexa's everyday advantages. Maybe can you give us an overview also on that and what these advantages are?
Yeah, so I think the advantages and the um, the fact that we're looking at a different space compared to Bitcoin should be obvious, right? So I included a slide that said, but versus like EVM blockchains, what are our advantages? So the first thing to understand is the UTXO architecture delivers a lot of advantages, um, especially in performance. You can execute like a massively parallel evaluation. The reason why is because it's very easy at the top to identify what parts of like the ledger are going to be changed. And so um, with very little sort of serial processing, you can identify transactions that won't conflict with each other. And so then you can execute all of the scripts in those transactions simultaneously. Um, and then also you can do it in between block discovery, because once a script has been evaluated as correct, the only way that it can be that the there's really no way that the script will be reevaluated as false. The reason why is because the script is being evaluated against static input data. And so again, all you have to check is that, oh, does that UTXO data, both the key and the value effectively, has that not changed? And so that's the only thing you have to check, and a block is discovered. So this allows you to be evaluating scripts not just when a block arrives, but throughout the whole inner block period. So all this, massively increases our ability to, evaluate and process transactions. And then finally, there's a lot of end-user usability stuff that has popped up in EVM systems, which UTXO systems and Nexa really shouldn't have. The first thing is an issue called MEV in Ethereum, which is short for maximal extractable value. And what MEV is the idea that because a transaction is being evaluated at the current state of the ledger, not a static known state, a miner or another interested party can front run a transaction or sandwich it, like put a transaction before and after, in order to cause the target transaction to be more expensive than expected. So the simplest example is if you just kind of like spam the buy button for a token without explicitly putting in a maximum price, right? So then, a miner, typically it's miners who do this because it's sort of free money, and so they have the ability to inject transactions into their own blocks, would buy up that token to raise the price dramatically, and then you'll make your buy against the tokens that the miners just bought for a much higher price. So, and then of course the price would fall right back down. So that's a simple example of how you can extract value from transactions that aren't very carefully created. And if you search around for MEV online, you'll see that there, like, a lot of money, millions of dollars, has been stolen using these techniques. And then the second problem is the blind signing problem. And then, so what that basically is in Ethereum, since the scripts are Turing complete programs. They're just like normal programs that run against the ledger. They can make any changes they want to the ledger. Okay, and a long time ago, a computer scientist proved that another computer program cannot analyze a sufficiently complex computer program and figure out what exactly it's doing. It's called the halting problem in computer science. And so what that means is, like, your wallet can't look at another, like the contract, and really extract out what's going to happen. And so you end up like trusting in Ethereum, right, the contract, or you have to manually review it yourself. So you have to be an expert in, Ethereum's contracting language, which seems unlikely for the vast majority of people. And this if you search Google, this is called the blind signing problem, and people have lost. The one that popped into my mind is, like, someone lost an Angry Ape because what happened was they were tricked into having their wallet trust a website that was spoofing another website, and then the website was supposed to airdrop a new NFT, but in fact it stole the Angry Ape NFT. Okay. So for Nexa, though, that's not the case. Exactly what changes a transaction is going to do to the ledger is right up on top. Here's the list, and that's it. So we can just place that right in the wallet, like a Wally wallet will just pop up a screen saying, here's a special transaction incoming. You're going to receive an asset, and you're going to spend 20 million Nexa. That's it. That's exactly what's going to happen. That's guaranteed. Nothing else can happen. So that, I think, is really going to help end user usability, which is the goal that I'm looking for. And then in a similar way, because these transactions, the scripts execute deterministically, we don't really need gas, which is this Ethereum way to make sure that transactions aren't like runaway. The scripts execute forever. And people have gotten tricked into spending way too much gas. I spent $10,000 in gas for a very small transfer because, again, the transaction wasn't formatted correctly, and a miner did a MEV trick to jump the the price of gas way up, or trick your transaction into an infinite loop. Okay, and then finally, one thing that Nexa has in particular is intrinsic token enforcement, or what we call native tokens. And that means that tokens are not a script implemented on top of the blockchain. Tokens are fundamental primitives in the blockchain, and the enforcement of, say, the conservation of quantity of a token in a transaction is a fundamental blockchain level enforced rule, just like it is for the fundamental or native token of, and that's why we call it native tokens sometimes, is because like the tokens themselves are just like the primitive original token of the blockchain, in this case Nexa, right? So we have this intrinsic token enforcement, which makes things a lot more efficient. You don't have to build an entire script just to create a token. You can just create one. And that also means that as an end user, technically, if you receive a token, you really should review the smart contract associated with that token to make sure that it's correct, right? Who does that? So you have to kind of trust and hope that that smart contract actually implements the token correctly. But in Nexa, you don't really have to do that because it's a primitive. So those are the big advantages.
Oh, thanks a lot. I had
Sorry I went on
prepared.
for a while.
Yes, I had prepared it for a couple more questions, but you already covered them. So maybe I will get back to the beginning where you've started, and I want to get back to UXO versus EVM model. I know we have a lot of advantages in scaling in parallel versus EVM accountant model. Maybe you could highlight some of them or explain how it is and how much scalable it can be.
Yeah, so the UTXO model, okay, so the EVM model, let's start with that, is more just like a database. It's what you think of as a database. Okay, and so what that means is, hey, you have key value pairs and you want to write a value to this database. You want to update the quantity of your account, right? How much money you have. And so a EVM script, is a program that makes changes to that database. And typically, for example, a token is a token works like this in Solidity. It's create a hash table of addresses and quantities, and then I'm gonna if a transfer happens, look up the from address and deduct one from that, or whatever the quantity is, and then look up the to address and if it's not there, add it in, and then add one to that. Okay, but it doesn't have to be implemented like that. Um, and of course, there's often qualifications and things that people throw in. So you see, so on the UTXO side, though, the entire ledger is basically key value pairs, and you're only allowed two operations. One is consume a key value pair, like use it up and destroy it, and then create another one. So there's no such thing as updating an entry. And what that means is that a transaction then cannot use a value that's been updated to something that they don't expect, and so the transaction does something unexpected, like spend a huge amount of money for a token that really ought to be cost a lot less. What would end up happening in Nexa is it would say, oh, read the UTXO that says the price of this token. Oh, that UTXO doesn't exist anymore. Transaction is bad. The end user needs to reissue it. So if you try a MEV move and you try and front run a transaction, the worst that can happen is that the end user has to reissue the transaction. So it becomes, in the worst case, a denial of service attack. But in practice, that seems unlikely because the attacker would have to continually, every time it sees your transaction, it would have to create a transaction that conflicts with it and would have to win that race. And also, it's spending money to do so.
So yeah, in essence, Nexa also saw sorting maximum extractable value problem with backend infrastructure with UTXO. So that's really nice. Probably we covered the majority of the talk, and it's supposed not to be a long spaces, not long AMA format. So Maybe lastly, let's talk about native tokens. Maybe we can have a little overview or a teaser from Spaces with you. Yeah, I'm going to give a teaser that in a couple of weeks we're going to have a second part of your speech. So I think our native tokens fundamentally plays a crucial in atomic secret exchange, which review is coming. How does Nexa handle tokens differently, and what are its advantages?
Right. So a token in Nexa is a 32 byte identifier, and then obviously a quantity, and that's part of the UTXOs. The UTXO can carry Nexa and a single token, not a single like a quantity of one of it, but a single token type with a particular quantity. And to stop obviously people like minting the same token types, you don't get to choose that identifier. You mine it, but the identifier is effectively a it's just like in mining, it's I hate to say a random value, but from your perspective, it's a random value, but it's a value derived from hashing some input quantities which provide entropy into the system. So you can't easily, like, I shouldn't even say easily. It's probabilistically impossible. It's infeasible to create a token that type that conflicts with another token type in just the same way that it's infeasible, effectively impossible for two people to have end up creating Bitcoin addresses that happen to be the exact same address. Okay, so given that, we have primitives in the block enforcement, right? It's part of consensus to say, oh, if 13 of this token type has been brought into the transaction, then 13 must be brought out, must be sent out. So conservation of quantity, unless, of course, you have an authority that allows you to break some of these conservation rules. And the original token creator begins with these authorities. And if they wanted to create, for example, a token that stops that will never be any more, will never have any more minting, then what they can do is just basically burn the authority, so they can prove that no other tokens will be created. Or they can do the same thing for melting or destroying tokens. You can burn the melt authority. And so that's basically how it works. And so these are first order primitives on the blockchain, just like Nexa is.
Yeah,
Now,
so
I guess I should talk about how this connects into atomic secret exchange. And the issue is kind of like, okay, so right on top of tokens, we have the idea of an NFT, right? Which is a token that there's just one of. And you can attach some data to an NFT. And I thought it'd be really interesting to be able to have data that is special to the owner, and only the owner can see it. So how would you do that? Well, you would need to give like you could take an encrypted file and stick it in the NFT's data, but you'd need the key to that encrypted file, right? And so what we need, and so as a more general problem, what we need to be able to do is we need to be able to sell a secret, which if you think about it, that's like impossible to do in real life in a trustless way. Like you could give a person money and they could tell you 42, and you're like, no, that's not the meaning of life, right? That's just a number. So I think this is really interesting because it does something that you can't even really do in real life. So the idea is that what we need to do is have a trustless, anonymous, permissionless, and decentralized technique to atomically exchange an asset and a secret. And then the blockchain must verify the continuity of the secret. And what I mean by that is, look, the blockchain can't prove that a particular secret unlocks a website or whatever that's external to the blockchain itself, right? But what it can prove is that the same secret was given to you that was given to the previous, person who owned the token, and the one before that, and the one before that. So that's what I mean by the continuity of the secret. And the blockchain must verify that the secret was transferred. Um, and then here's the important part. Of course, both of those things need to happen without gaining any knowledge of the secret, because anyone can look inside the blockchain. It's a public data structure, and they would be able to pull out the secret. So we need this blockchain system to do something that is kind of shocking, and that is to verify properties of the secret without itself gaining any knowledge of the secret. And so I've developed a protocol to do that, which we'll talk about next time.
Yes, this is huge. Andrew, thank you so much for your time and sharing all the insights, walking us through Nexa key points. Maybe you have something else to add before we end today's spaces?
No, I think that's it. Are there any questions? Did you get questions from the
No,
public?
for this time, we didn't get any questions because it was a simple Nexa review and ACC introduction. And for the next upcoming spaces in a couple of weeks, we will do that for the second part of your speech.
Okay, sounds great. Yeah.
Yeah, thank you again, Andrew. It was a pleasure to talk with you today. For everyone else, stay tuned for our next spaces with Andrew, where we will explore even more exciting developments with Atomic Secret Exchange and private NFTs. Don't forget to check out on our website, join our community channels, and make sure to watch our pinned video in the main channel on X here, where you will find Andrew's live speech at the Crypto Convention in Sydney. Also, a spoiler that next week we will have another request from the Nexa team here before interview with Andrew Stone again. So thanks for joining us today, everyone. See you soon and bye bye.
Thanks, Endo.